Okay, we have this first question here. So the first thing you want to figure out is, am I using a z interval, a t interval, or am I talking about a proportion? You read through the question, notice that sigma is not given, so we assume sigma is unknown. And if we don't know sigma, that implies we're going to use a t interval. So I'm given the data in the form of a list, so I'm going to start by inputting that list into my calculator. So I'm going to go to stat edit. I've already done that. Just put all your data values into L1. Now to run my interval, my confidence interval, I'm going to hit stat again, go over to tests. And since I don't know sigma, I'm going to go down to 8, which is a t interval. And I'm going to input data, not statistics, data. The data I input was from L1. They all have a frequency of 1. And my confidence level is going to be 95%. So I'll just hit calculate. And it says round to 2 decimal places. So this will be 36.52 to 69.12. And that's it. The next one talks about the sample size for a proportion. So it wants to obtain a sample to estimate the population proportion. There it is, right in the middle, sorry. So I copied the formula for this. This is from the PowerPoint notes. This is from slide number 64. This is the sample size for a proportion. So I just need to pull out all the appropriate numbers and calculate this thing. So we have no reasonable estimate for p hat for the population proportion. So we assume that p hat is equal to 50% because we don't have an estimate, which is also going to be what q hat equals, because q hat is just 1 minus p hat. We're looking for the z that cuts off the middle 99.5%. So I'll draw a quick picture. So we're looking for this z value. This will be negative z. That cuts off 0.995. And we're looking for a margin of error of 0.1%. So E is going to be 0.1. Okay, so first thing I'll do is figure out what the z value is going to be. So I'm going to hit distribution, inverse normal to get that z value. The area to the left of this, since this is 99.5, this is going to be 0.0025, and this is going to be 0.0025. So then that means to the left of this would be 0.9975. Mu and sigma are 0 and 1. So that's going to be my z value, 2.807. So notice the first thing I'm going to do is take that number and square it. Then multiply that by p hat by q hat, so times 0.50 times 0.50. So this thing is my whole numerator. Now I'm going to divide by 0.1 squared. I get that. And I'm going to take my numerator and divide by my denominator. Now, wait a minute, that's not exactly correct. Why is that not correct? Well, because my margin of error, I need to translate that to a decimal. That's my mistake. This was 0.1%. So my margin of error should be 0.001. Move that decimal 2 places to the left. Now it should work better. So this is still my numerator. So now I'm just going to go up, clear this, and clear this. So now I'll do 0.001 squared. And then I'll take my numerator and divide by my denominator. This will be a much better answer. Yep. So I have 196,9859.6. Always round that up. That's 196,9860. And there you go.